All right, this one is a little bit more, I wouldn't say difficult, I would say a little bit more complicated. We have two rectangular signal, widths of each one is 10, and for rectangular signal, we know t over 10, sorry, this equals 1 if t is between -5 and 5, and if t is larger than 5 or t is smaller than -5, then the value of the signal is 0. And if I want to plot that, it looks like something like this. This is 1. And this is rect of t over 10. Okay, so we want to calculate this convolution, and we know that this yt equals integral from -infinity to infinity of rectangular of tau over 10 times rectangular of t minus tau over 10 theta. Okay, so we have two signals, we have to calculate the product of these two signals from -infinity to infinity and calculate the integral. Let's first plot these two signals, this one and this one. I plot the signals here. Okay, this is t, and let's first plot this one, rectangular of tau over 10. Well, we gave the expression for that. We know rectangular of tau over 10 equals 1 if tau is between -5 and 5. So if this is 5 and this is -5, the value of the signal is 1 in this time interval, and the value of the signal is 0 for tau larger than 5 or tau smaller than -5. Okay, so this is rectangular of tau over 10. What about this one, rectangular of t minus tau over 10? To plot that, we can first consider rectangular of tau over 10. Well, we have it here, and then based on that we can invert it over time, rectangular, and calculate rectangular of minus tau over 10. Okay, so it's a time inverted version of this signal, and if I flip this signal over this vertical axis, then we get the same signal because it's symmetric across this vertical axis. Okay, so this also equals rectangular of minus tau over 10. And if I shift this signal by t, so then we would have rectangular of t minus tau over 10. And that's the time shift, okay? Time shift. So if t is positive, we have a shift to the right. So we would have something like, let me use different color. We would have a shift to the right of this signal, so it would be something like this. And this is t, so this would be t minus t minus 5 over t minus 5, and this would be t plus 5. Okay, so for positive value of t, we have a shift of this signal to the right, and for negative value of t, we have a shift to the left, and it would be something like this. Okay, and again, this is t minus 5, and this is t plus 5, and this is t in the middle. Okay, so you see that this signal that we have it here is a time shifted version of this signal, and we want to calculate the product of these two signals, but we don't know the value of t. We should change t from negative infinity to infinity, because we don't know the exact value of t. Okay, so let me assume t is very small, t is negative, for example. I'll start by that, so let me remove this part. Okay, let me stop the video. Alright, well, I removed everything and moved this expression for the convolution here to the right. Here we assume that t is very small, smaller than 0 even. And, well, to calculate the convolution for this particular value of t, we should calculate the product of these two signals from minus infinity to infinity. And it's obvious that the product of these two signals is actually 0. So this is rectangular signal of t minus tau over 10 for t smaller than 0, much smaller than 0 actually. So the product of these two signals is 0, and that's because the non-zero part of this signal, the non-zero part of the signal overlaps with the 0 part of this signal. Okay, you see in the interval from minus 5 to 5, this signal is 0, and the non-zero part of this signal overlaps with the 0 part of this signal. So that's why the product of this signal is 0. We can also check that by this expression here. Well, we know the rectangular signal for t minus tau over 10 is either 1 if t minus tau is smaller than 5, and is 0 if t minus tau is larger than 5. If I expand this, then I can write, after some simplification, we can write the value of the signal is 1 if tau is between between t minus 5 and t plus 5. And that's what we have shown here, okay? Okay, if I replace this to the integral above, then I can write the integral like this. Instead of negative infinity to infinity, I can write from t minus 5 to t plus 5 of rectangle of t over 10 times this, and this is 1 in this interval. Okay, so I don't need to write anything, just d tau. All right. Now take a very small value for t. For example, assume t is, I don't know, t is minus 100. Okay, very small. That means we have shifted this signal to the very left. So this integration becomes minus 100 minus 5 is minus 105 to minus 95 of rectangular of t over tau over 10 d tau. All right, and we know the value of this signal rectangular of tau over 10 is 1 if tau is between minus 5 to 5. Otherwise it is 0. Okay, and that's what we have shown, we have plotted here. So that means the value of the signal in this range, the value of this signal in this range from minus 105 to minus 95 is 0, because tau is below minus 5. Okay, so this totally becomes 0, and that's what we said here. If you multiply these two signals, you will get 0, because they are too far from each other, and the non-zero part of this signal overlaps with the 0 part of this signal, and the non-zero part of this signal overlaps with the 0 part of this signal. All right, so you see when t is too small, for example t is minus 100, then yt is 0. Let me plot minus yt here. So this is t, this is yt, and we saw that for t equals minus 100, yt is 0. So assume that t is minus 100 here. Now I shift the signal to the left. So I take a smaller value for t. For example, t is minus 200. Applying the same approach, we get that the value of this multiplication is 0. This integral is 0. So for a small t, I would say the value of the signal, the value of yt is 0. Okay. And now I start shifting the signal to the right. Instead of taking t equals to minus 100, I take t equals minus 50. Again, if I do the calculation, I see that the value of yt for t equals minus 50 is 0 again. So I keep shifting this signal, the blue signal, I keep shifting this signal to the right by changing the value, because I said that t is going to be changed from minus infinity to infinity. Okay, so I took t equals minus 200, I assumed t is minus 100, I assumed t is minus 50, and for each one I calculated the value of this product and this integral, and I got 0 for all. So I keep shifting this signal, and I shift the signal to the right. Say if I shift it to the right, you would have something like this. And you see there is no overlap between non-zero part of this signal and non-zero part of this signal. So I keep shifting, and if I keep shifting, if I keep shifting, if I keep shifting the signal to the right, we'll finally see an overlap between these two signals. Okay, and that happens here. So the overlap happens when the right edge of this signal overlaps with the left edge of this signal. And that happens when this value equals this value. T plus 5 equals minus 5, and that means when t equals minus 10. Okay, so when t equals minus 10, there is overlap between these two signals, between the, not the signals actually, between their non-zero part of the signals, and that means the product can be something other than 0. So let's calculate that. So from this, I want to calculate the value of the signal. So I saw that the overlap happens when t equals minus 10. So we have minus 15 here, and here you have minus 5 of rectangular of tau over 10 d tau. And we saw that this signal is 1 if tau is between minus 5 and 5. Okay, so but tau here is between minus 15 and minus 5. Okay, so you see that at one point at least the value of this signal becomes 1. Okay, good. So we can say that the product equals 1 at t equals 10. We can calculate the integral, but let's skip that to save some time, but I think that's quite obvious for you to calculate that. So at t equals minus 10, there is a jump in the value of yt becomes 1. If I further shift this signal, to the right, what happens? We would have a larger overlap. Okay, so shifting signal to the right means increasing t. For example, increasing t from minus 10 to minus 9. Then there will be a larger overlap between two signals. And this time, if you calculate the integral from minus 14, because t is minus 9, so minus 9 minus 5 is minus 14, to minus 4, you would see that the value of the integral equals 2. So there is another increase. Okay, so just assume this is minus 9 and this is minus 10. Let's make some space. This is minus 10. And if I further shift the signal to the right by increasing t from minus 9 to minus 8 and then minus 7 and then go to 0, at 0 both signals perfectly overlap. The blue signal perfectly overlap with the reddish signal, and that's where the value of this integral is maximized. Actually, that's where yt which is y0, because t is 0, equals integral from minus 5 to 5 of rectangular of tau over 10 d tau. And we know that the value of this signal in all range in whole interval from minus 5 to 5 is 1. So we have integral of d tau from minus 5 to 5, and this is 10. So if I further shift the signal to the right, we reach the maximum overlap and the maximum value for the integral, which is 10, equal to the width of the signal. Okay, and if I again continue shifting the signal by increasing t from 0 to 1 and then 2 and then 3, then finally we would have the blue signal here. You see the overlap is decreasing, and if I apply everything we did for the value of t below 0, for those t larger than 0, you will see that there is there is decrease in the value of the integral, so we would see such a thing. And at t equals 10, you see that the product again becomes 0, and again if you shift the signal to the right, furthermore these two signals, blue and red, will become more far and far, and their product is 0. We would have the signal here for large value of t, and you see the product of this signal to this signal would be 0, because the non-zero part of this signal overlaps with 0 part of this signal, and the non-zero part of this signal overlaps with 0 part of the blue signal, so their product becomes 0. So this is the convolution of these two signals. You could reach to this from calculating the integral, as I did for few of the values of t. You can do that for all values of t from from negative infinity to infinity, and by increasing t step by step you can calculate the convolution, or you can do the same approach as we did here. Just graphically we showed that what does it mean increasing t. That means shifting the signal to the right, and when you shift the signal to the right from left, at some point there is overlap, and when there is overlap, the value of the integral becomes non-zero, and you see that as you shift the signal at that time to the right, the value of the integral increases, and then the value of the signal monotonically decreases, and after a while the value of the integral becomes 0, and that's when the two signals are far from each other.